All right, for the 6.3 notes, we're going to build towards figuring out the trig functions for some angle. We're going to be using the unit circle and all that fun stuff and using our special right triangle rules as well. But before we get to that, we have to know a little bit about reference angles. The reference angle is always going to be the acute angle to the x-axis. Big key there is x-axis. So if I gave you an angle of, say, 143 degrees or something like that, that angle would terminate in the second quadrant. Positive angles rotate clockwise, remember, or excuse me, counterclockwise. So whatever that angle is, let's just call it theta. So that was my spinner rotating to there. That was it stopping. That's its terminal side. The reference angle would then be this angle to the x-axis. That's your reference angle. So it's always to the x-axis, and it's going to be that little less than 90 angle. The trig functions, they're signs, S-I-G-N, like positive or negative. That's based off of what quadrant you are in. And the acronym that I like to use is all students take calculus, and hopefully you'll all take calculus after this. The first quadrant is the A, the second quadrant is the S, the T, and the C. What this tells you is who is positive. So in the first quadrant, it literally means all are positive. So everybody's positive in the first quadrant. In the second quadrant, S actually stands for sine. Only the sine is positive in the second quadrant. In the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. Now I am saying only the cosine, the reciprocal, which is secant, would also be positive. Because if you flip a positive number, it's still positive. But I'm talking about the big three, sine, cosine, tangent. So you'll hear me say in the notes several times, all students take calculus. I'm referencing this acronym to tell me if it's positive or negative. But we'll get into that in just a little bit. Some practice on reference angles. 160 degrees. Well, 160 degrees would land me right about here. The reference angle would be this acute angle. So all I'd have to do is 180 minus 160, oops, 160. And my reference is 20 degrees. Negative 290, well, that would rotate the other direction. If I think about it, 290, well, we've got 90, 180, 270. 290 would land me somewhere up here. My reference angle, again, is the acute angle to the x-axis. So ask yourself, all right, I went 20 degrees past the positive y-axis. I know that's 90 degrees total. That would leave me with 70 degrees left over. On letter C, I'm in radians now, so we're going to answer in radians. Remember that a half circle is pi radians. A quarter of a circle is pi over 2 radians. 8 over 9 is in between those two numbers. So 8 pi over 9 must be somewhere over here. Kind of like we did on the first problem, but in radians, I'm going to take pi radians and subtract off 8 pi over 9. That would be 9/9 minus 8/9. So 1 pi over 9 would be that little reference angle. For letter D, 16 pi over 3. Well, remember, a full circle is 2 pi. Well, 16 over 3 is way more than 2. So what this means is that I'm doing some extra spinning. Every full spin is 6 over 3. Because again, a full spin is 2 pi, so that would be 2 pi, or 6 over 3 pi. So 6, 12. If I did another full spin, I know I would be past 16 over 3. So here's where I'm at. 16 pi over 3, I'm going to subtract off 12 pi over 3. This is basically doing that coterminal angle stuff. So I'm subtracting off those 2 full spins. That leaves me with 4 over 3 left over. Okay, well, where's 4 over 3? Well, 4 pi over 3 this is pi, and this is 3 pi over 2. 4 pi over 3 is in between those. So this is going to continue to spin and land somewhere down here. So my spinner landed down here. Again, the reference angle is always to the x-axis. Let's think how far we went. On that last half circle, this was pi. So if I take 4 pi over 3 and I subtract off that amount, pi, that means the leftover, the blue part, is 1 pi over 3. That's my reference angle. So now that we have a little idea of reference angles, now we can start to build the idea of doing trig in other quadrants besides just in the first quadrant. But we're going to kind of build the idea here with these 2 examples. So these aren't actual problems, but these are building the idea of how we figure out the trig function. So consider a point on the coordinate plane. So it's got a coordinates x, y. We're going to build triangles off of the point, always to the x-axis. So we're going to build a right triangle. The sides of this triangle, well, the horizontal is just whatever the x value is. The vertical is whatever the y value is. The hypotenuse, I'm going to call r for radius because I'm building this idea of unit circle. So the sine from the angle theta, sine is opposite over hypotenuse. So this would be y over r. The cosine is adjacent over hypotenuse. That's y over x. The tangent is opposite over adjacent. Oh, I'm sorry. I did the cosine wrong. Sorry about that. It's y over r. Nope, it's not. Let's try again. Got ahead of myself. I got to the tangent. All right, let's try that again. Cosine is adjacent over hypotenuse. There we go. X over r. Tangent is opposite over adjacent. Y over x. But I keep talking about this unit circle. What does that mean? That means it's a circle with a radius of 1. So imagine that point P being on a circle going around here that has a radius of 1. That actually simplifies the problem. I'm still going to drop down and build myself a little right triangle here. This is still x, this is still y. But now watch what happens. The sine is opposite over hypotenuse. Well, y over 1 is just y. The cosine is adjacent over hypotenuse, x over 1, which is x. The tangent, nothing changes, it's y over x. But what does this mean? This means that if I'm on the unit circle, then the coordinates of the point, the x is really just the cosine of the angle, because I figured out that the cosine equals x. The y coordinate is the sine of the angle. And this also shows me if tangent is y over x, tangent can also be thought of as the sine over the cosine. So I'm going to use all these facts along with the triangles to start actually calculating some trig values here. So there's several steps in this process. The first step is to figure out where my angle actually is, and that goes back to knowing the radian angles on the unit circle. Every single time I draw a quick little XY plane to represent my unit circle coordinates, and I'm going to ask myself, okay, my denominator of the fraction is 4. That means I'm counting in 45-degree increments. Because every 1 pi over 4 is 45. So 1 pi over 4 would be 45, 2 pi over 4, 3 pi over 4. Okay, so here's where 3 pi over 4 lands. So my spinner landed here. Build yourself a right triangle to the x-axis, always to the x-axis. Now remember, if I'm assuming this spinner is on the unit circle, that spinner has a length of 1. Well, what's my reference angle? You can write it in radians, but I think it's easier in degrees. I was counting in increments of 45, so this must be a 45 reference. Now I go back to what I learned at the beginning of this chapter. To go from a leg to the hypotenuse on a 45-45, I multiply by √2. So to backtrack, I have to divide the hypotenuse by √2. Which if I then rationalize that, times top and bottom by √2, I get √2 over 2. Remember, it's a 45-45, so both legs are the same. They're both √2 over 2. Okay, so I've built my triangle. I've marked the sides just by knowing my special right triangle rules. Now I can actually solve the question. It wants to know the cosine of this. So from my angle, it's always from the reference angle, cosine is adjacent over hypotenuse. But notice, since we're on the unit circle, the hypotenuse is 1, so we don't really care. We're dividing by 1. So it's really just the √2 over 2. Now there's one extra hitch, and that's that I have to remember that all students take calculus. In the second quadrant, only the sine is positive, which would mean the cosine is negative. And there's my answer. Now also notice I was finding the cosine, which really also means, we go back up here, I was just finding really the x value, the x distance. Well, the x distance to that point is back √2 over 2, which is what I found, negative √2 over 2. They all mean the same thing. You're going to see that there's several ways to kind of attack these. Letter B. All right, my first step is to figure out where the heck my angle lands. Now, with my counting method, here's the rule that you got to remember. If it's over 3, make it over 6 so that you can count by 1/6 increments. So 16 over 3 is the same thing as 32 over 6. If I multiply top and bottom by 2. Don't worry about the pi, we know pi's in it. Every 30 degrees is 1/6. So this is going to take a little bit, but I'm going to start counting. So 1/6, 2/6, 3/6, 30, 60, 90. 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that was 12 over 6. I'm nowhere near 32 yet. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, remember I got to get to 32. 25, 26, 27, 28, 29, 30, 31, 32. Now, there can be faster ways to do that, but that is just counting 1/6 at a time. So I landed down here. Remember, this has a length of 1. So it spun around 2 full times, landed there. This is the same as one of the reference angle problems we did. Build your triangle to the x-axis from that point. And again, the next question now is, what is the reference here? Well, I ticked twice. So that's 2 30s that I ticked. So this is 60. Okay, now I'm ready to label the sides of my triangle. And this is where I have to use the special right triangle rules. On the 30, 60, 90, the short leg is half the hypotenuse. So if the hypotenuse is 1, the short leg is a half. The long leg is the short leg times √3. So if I times 1/2 by √3, I get √3 over 2. Basically, there's 2 triangles that we're going to be looking at. The 45, 45, 90 and this 30, 60, 90. They have the same side lengths, they just get rearranged in different quadrants. Okay. What is it asking for? It is asking for the sine and ask yourself, oh, will that be positive or negative? Well, all students take calculus. I'm in the quadrant where only tangent is positive, so the sine's going to be negative. Sine is opposite over hypotenuse, or I can think of sine as the y distance. Either way, it's the same thing. It's negative √3 over 2. The same answers are going to keep repeating themselves over and over on this because we only have 2 special right triangles. There's only so many side lengths that I can use. For letter C, again, first step, figure out where your angle lands. Pi over 2, that's 90 degrees. It is negative though, so realize that I'm actually rotating 90 degrees negatively and landing down here. Now, when I land on an axis, things are a little bit different. I can't build a triangle back to the x-axis, a right triangle, because it would just overlap my line that I'm already on. These are actually easier. Remember that this spinner has a length of 1, which means the coordinates this landed at are 0, -1. Remember what we went over up here. If I'm on the unit circle, which I am, the x coordinate is the cosine. The y coordinate is the sine. So I don't even have to actually do any triangle work. That's the cosine right there. So the cosine of -pi over 2 is 0. Had I asked you for the sine, it would be -1. And that's it. For letter D, now we're doing the tangent. Same angle though. So again, -pi over 2 lands me straight down. Coordinates 0, -1. Well, the tangent is, and we'll do this more and more, the tangent can be thought of as the sine over the cosine, which I proved up above. Well, the sine is -1, because remember it goes cosine followed by sine for the coordinates. So the sine is -1, the cosine is 0. Well, -1 divided by 0, all crap, thou shalt not divide by 0. This is undefined. I cannot take the tangent of -pi/2. For letter E, cosecant. Oh boy. All right. Think of its reciprocal. The reciprocal of cosecant, careful, is sine. So we're going to run this like it's a sine problem, and then I'm just going to flip the fraction at the end. So run it like it's a sine problem for right now. All right, I got to figure out where my angle lands. It's negative, so I know I'm rotating clockwise. 5 pi over 6. Okay, it's over 6. Being over 6 means you're counting in 30-degree increments. So 1/6, 2/6, 3/6, 4/6, 5/6. That's where my spinner landed. It has a length of 1. Always build your triangle to the x-axis. Well, I went 30, 60. My reference must be one more 30 increment. That will get me back to the 90 degrees. So I have another 30, 60, 90. It's the same exact triangle as I had up here, the same side lengths. The side lengths don't change. It's just been oriented a little differently. The short leg is still a half. The long leg is √3/2. So the short leg here is a half. The long leg is √3/2. Again, I'm running this as if I was finding the sine. The sine would be, all students take calculus, the sine would be -1/2. Again, all students take calculus, only tangent's positive down here, so the sine would be negative. Now the last thing I have to do is, oh wait, I want cosecant. So take that fraction and flip it, and your answer would be -2. For letter F, 5 pi. So again, figure out where 5 pi lands. Well, every 1 pi is 180. So 1 pi, I'm rotating 180. 2 pi, 3 pi, 4 pi, 5 pi. So my spinner went around a little bit, but what matters is that it landed on the negative x-axis. Remember, if you land on an axis, things are actually easier. Remember, this spinner has a length of 1, so that means the coordinates of this point are -1, 0. Remember that those coordinates represent the cosine and the sine. Tangent is sine over cosine. So it would be 0 over -1. You are allowed to have 0 on top. So the tangent of 5 pi is 0. All right, we'll finish up this section on the next video.